Good morning, children. This is ninth Physics, Chapter 8, Motion. Today we are going to start with the topic velocity. So let's see the learning objectives of this period. Now, children, at the end of the class, we will be able to define velocity. We will know the SI unit of velocity. We will be able to know the various terms such as what is uniform velocity, what is non-uniform velocity? We will be able to calculate the average velocity, and we will be able to define the instantaneous velocity. And then we will solve some numericals based on average speed. Right, children? So, let's start with today's class first topic. Now, children, last class we had done speed, right, children? So we know speed was the distance upon time taken. Now here velocity is speed plus direction, means your magnitude. Suppose you are moving with a speed of 30 kilometers per hour, and if we add a direction to this, that is 30 kilometers per hour, if you say towards north, right, or if you say 30 kilometers per hour towards the railway station, then what you are doing, you are adding direction to the speed. So now this physical quantity is your velocity. So velocity is speed along with the direction, right, children? So velocity is defined as speed of an object, but direction is to be added here, right, moving in a definite direction. Okay, children, so this is your definition for velocity. Now, as we know, speed equals to distance upon time, and we know speed is a scalar quantity, right, children? Here, velocity is displacement per unit time. So either you can define velocity in terms of displacement per unit time, or you can define velocity in terms of speed in a definite direction, right, children? So its formula will be velocity equals to displacement upon time. Now let's talk about the SI unit. So children, it is having the same unit as that of speed. So it is meter per second, and you can write it as meter s raised to -1. Right, children? And now it is a vector quantity, but obvious because we have specified direction also, right? And its SI unit is meter per second. Its SI unit is meter per second. Okay, children. Now let's move on. Now here, children, velocity can be positive, it can be zero, or it can be negative, because we have done that these are the three possible results for displacement also. Displacement is possible positive, zero, and negative. So when the object is moving towards the origin, when it is returning towards its initial position, right, then your displacement will be negative. And when the initial position and final position is same, initial position, for example, the object started from this point, an athlete is running on a circular track, and after covering the entire track, he is returning to the same point A. So his initial point is A and final point is A. So his displacement is 0. So for displacement equals to 0, velocity is 0. For displacement negative, velocity will be negative. For displacement positive, the velocity will be positive. Yes, children. Now, how can you change velocity? Velocity can be changed by three ways. Firstly, if you change the speed, suppose initially you were moving with a speed of 30 kilometers per hour, and then you start moving with a speed of 35 kilometers per hour. So as you have changed the speed, the velocity has changed, because velocity is what? Velocity is speed plus direction. Velocity is speed plus direction. Yes, children. So speed change हो गया. So velocity has changed. Now, suppose you change the direction. You take a turn, right? Initially, you were moving on a straight path. You were moving in a straight direction. Now you have changed your direction. So on changing the direction, the velocity changes. And if you suppose change both, you change the speed as well as you change direction, then also velocity will be changed. So velocity can be changed by changing the object speed, by changing the direction of motion, and by changing both speed as well as the direction of motion. Right, children? Now, next is we are going to classify velocity as uniform velocity and non-uniform velocity. Same we did for speed. Uniform means as we all wear uniforms in school, we all look equal. So your velocity, we know it is displacement upon time. So if a body covers equal displacement in equal time without changing the direction, then the velocity is said to be uniform velocity. Equal displacement upon equal time, right? But direction भी change नहीं होना चाहिए, right beta? Without changing the direction, then the velocity is known as uniform velocity or constant velocity, right children? Non-uniform velocity, when the displacement is not equal. Here it is equal displacement, here it is unequal displacement, so only it's non-uniform na beta. So if an object covers unequal distance in equal interval of time, then the velocity is known as non-uniform velocity, or it is also called variable velocity. Its example can be a car moving in a traffic area, a car moving in a crowded place, a car moving in a market area, right? So a non-uniform velocity, because when you enter a market on your Activa, you have to take turns, this side, that side, right side, you have to change your direction. And if you see someone approaching towards you, you have to apply brakes, and if you see some space is clear for your Activa to proceed, you will accelerate it. So your velocity is constantly changing, it is not equal. So that is an example for non-uniform velocity, right children? Now the next topic was average velocity. Now we know the meaning of the word average. So here also, as we know, velocity is what it is, displacement upon time. So average is total displacement upon total time, right children? So average velocity is what? Total displacement upon total time, है ना बेटा? Average velocity, which is denoted by VAV, it is total displacement upon total time. Now this formula for average velocity you can apply only when your velocity is changing at non-uniform rate. It should not be uniform. If it is uniform, then you can simply just add the initial and final and divide by 2, right? But if it is non-uniform, for example, here I've shown you an example that is just a second children. This in this, yes, here. See children, suppose here this is the origin, right? This is your origin. From here you started on your Activa, right? And or on your in your car, and for first hour you have covered the distance. In 1 hour you have covered the distance of 30 kilometers. Then you are covering a distance of, in next 1 hour you are covering a distance of 20 kilometers. So here your velocity is 30 kilometers per hour. In the second slot, your velocity is 20 by 1, that is 20 kilometers per hour. In the next 1 hour, you are covering a distance of 10 kilometers. So here your velocity will be 10 kilometer by 1 hour, that is 10 kilometer per hour. So here you can see that the velocity is not uniform, it is non-uniform. So if you want to find out the average velocity, what you will do, you will just divide total displacement upon total time taken, right? That is the displacement, the shortest distance between the initial position and the final position upon total time. Now let's see, in case of uniform rate, means if your object is traveling equal distance in equal interval of time, and that too the object is moving in the same path, then how can we find the average velocity? Right, children? That is this case. So this is your path of the object, right? So here the time interval is of 1 hour, right, children? So for 6 hours the car is moving. Here 30 kilometers in each hour slot, the car is moving a distance or a displacement of 30 kilometers. So it's equal, right? So this is your uniformly, it is changing. So when it is uniform, it's equal in every hour. The average velocity will be simply initial velocity plus final velocity divided by 2. So it is 30 kilometer per hour plus 30 kilometer per hour divided by 2. So it is 60 kilometer per hour divided by 2, that is 30 kilometer per hour. Right, children? So I hope you are clear with this. The next term is instantaneous velocity. I had explained you in instantaneous speed also, children. Yes? So instant. So you might have seen your mama also bringing instant idli pack, right? So what is instant in that? See, the traditional process of preparing idli takes about 1 to 2 days, right, children? But instant, just mama mixes the batter and just leave it for half an hour, and then idlis are ready, right, children? So instantaneous is also the same thing. Suppose you are moving on your Activa, and I also approach towards you on my Activa, and I just look at your look at you and I ask you what's your velocity at this time, and suppose we both are moving on a straight path, straight road. You'll just look into your speedometer and you will just tell me that, ma'am, my velocity is 50 kilometers per hour. So at that particular instant of time you're telling me. So that is your instantaneous velocity. So your velocity of an object at a particular instant of time, right, or at a particular point of its path is called the instantaneous velocity. Right, children? Chalo. Now let's proceed to the last part. Here we are going to discuss about the conditions. Here we are going to discuss about the conditions when the magnitude of average velocity of an object is equal to its average speed. Means they are asking you कि कब average velocity will be equal to average speed. So we know, children, the formula of average velocity and average speed. Average speed was total distance. Total average speed was total distance upon total time, and average velocity was total displacement upon total time. Now, children, if total distance is equal to total displacement, then we can say that average speed is equals to average velocity. Yes, children? So this is your answer to this question, that when the object travels in a straight line path, means object is traveling on straight path, direction is not changing, then the distance traveled is equals to displacement, and under such condition the average velocity of an object is equal to its average speed. Yes, children? Now we will cover the numerical number 1. Let's read the numerical. So children, this is your NCERT exercise of the chapter, which is on page number 112. question number 2 of it, right? This is question number 2. Let's read the question. Joseph jogs from one end A to the other end B of a straight 300-meter road. So Joseph is, children, he is doing jogging from point A to point B, which is at a distance of 300 meter. So from point A to point B, the distance is 300 meter. In what time? In 2 minutes 30 seconds, right children? 2 minutes 30 seconds. And then he turns around and jogs 100 meter back to point C in another 1 minute. And then beta, he is turning back and he is coming to point C in next 1 minute, right children? Simple. Now, what are the Joseph's average speed and velocity in jogging? So what you have to find? You have to find average speed. We know the formula for average speed is total distance by total time, and average velocity is total displacement by total time. For which two cases we have to find? Number 1 from A to B, and B, second question is from A to C, right? So from A to B, first we will find the total distance, total time, and total displacement, right? And total time. And then we will find from A to C. So let's first start from A to B. Okay, A to B. Now children, be very careful. When the person is moving from point A to B, it is the person is moving on a straight path, right? So distance is how much? How much distance is covering? 300 meters. And the displacement, that is in shortest distance between initial point and final point, is also same. As he is moving on a straight road, distance and displacement are equal. A B ही रहेगा. So distance is 300 meter and displacement is 300 meter. Time was 2 minutes 30 seconds. Now we will convert this minute into seconds. 1 minute is 60 seconds. So 2 minutes is 120 seconds. So 120 plus 30 is 150 seconds is the total time. Now we are having total distance, we are having total displacement, and we are having total time. So now we will calculate the average speed and average velocity. Yes children? So average speed is total distance by total time. Total distance is 300, total time 150. So your answer of average speed is 2 meters per second. Now average velocity, that is total displacement by total time. This total displacement is also 300 from A to B. So 300 by 150, the answer is 2 meters per second. So children, this is the condition under which the average speed is equals to average velocity. That is when the object is moving on a straight path. And when the object is moving on a straight path, the total distance is equal to total time. Right? Now let's see for the second case, that is from A to C. From A to C. So let's first see the diagram from A to C, children. So from A to C, the person is first going from A to B, and then children, he is returning and he is coming to point C, right? First the person is going from A to B, jogging kiya, and then he is returning to point C, right? So total distance, how much distance did he jogged? So he is jogging a distance of, first he went 300 meter, and then he went 100 meter back. If we read the question, it's 100 meter back. So total distance what he jogged when he reached point C from point A was 400 meter. But displacement, what is the total displacement? Displacement is the shortest distance between initial point and final point. So children, which one is the initial point? A is the initial point. And which one is the final point? C is the final point. So what is the shortest distance between them? This is 200. So your total displacement is 200 meter. And the time is same, children, right? Time is same. That is 2 minutes 30 seconds. What they have given to us in the question. That is equals to 150 seconds. So now we will use distance, total distance 400 meter, and total displacement as 200 meter. Right, children? And then we will find out the average speed and average velocity. So see, total distance 400 meter and displacement is 200 meter. And total time, acha sorry children, time here he is returning and he is taking 1 minute more, hai na beta? Sorry. So total time is 2 minutes 30 seconds and then he is taking 1 minute, is returning to point C and is taking 1 minute in that, hai na children? So we'll add 60 seconds to this, okay? So total time is beta 210 seconds, okay? So total distance 400, total time 210, let's divide, the answer is 1.90 meter per second, right? Average velocity. Average velocity, displacement 200 meter, total time 210 seconds, right? So your average velocity is 0.95 meter per second. Okay, children. Now, let's solve one more example. And children, this is your NCERT in-text question. And this is your question number 3. This is your question number 3 of your NCERT, which is given on page number 112, question 3. Let's read it. Abdul, while driving to school, computes the average speed for his trip to be 20 kilometers per hour. So Abdul is driving to school. So Abdul started from this. Suppose this is home of Abdul. From point A, he is starting and he is approaching towards point B where his school is, right? So what was his average speed? His average speed was 20 kilometers per hour. Now, while he is coming back on the return trip, on the same route, there is less traffic, and because of the less traffic, his average speed is now 40 kilometers per hour. Right, children? So now his average speed is 40 kilometers per hour. What we need to find out? What is the average speed for Abdul's trip? What is the average speed for Abdul's trip? So let's start with this. Sorry. Okay, children. Now, as we know, the distance, that is while going to school and while coming from school to home, is same, right? So the distance of the trip, the distance of one-way trip is S, and we know speed is distance by time. So if we make time subject to a formula, then we will get T equals to S upon V. T will go here and V will come down, right? So you'll have T equals to S by V. So we need to find out average speed. And for average speed, we know the formula, that is total distance by total time. So total distance, so we know the distance from home to school is S, and the distance from school to home will also be S because it's following the same path, right? So S plus S to S. But total time, that we don't have. So let's find out the time first, right? So first we are calculating the time for the trip when he is going to school. So when Abdul is going to school, suppose the time is T1. So T equals to S by V. S is speed. S is your distance and V is the speed, children. Hai na beta? So T1 equals to S by V1. Hai na beta? Similarly, T2 equals to, children, T2 equals to S, that is distance, upon speed, that is V2. So this is, children, V1, this is V2. We want total time. For total time, what we will do? We will add them. Right, children? So average speed is total distance by total time, which is equals to total distance S plus S. And total time T1 plus T2. Now we will put this value of total time over here, right? And let's see what we are getting. What we will get is this. S plus S is 2S, and we have substituted instead of T1 S plus V1 and instead of T2 S by V2. Now if we take S common, Then inside the bracket will be 1 by V1 plus 1 by V2. SS will get cancelled and you will have 2 upon 1 by V1 plus 1 by V2. Right, children? Now, what we will do? Now we will take the LCM. The LCM is V1 by V2. So here we will multiply by V2 and here we will multiply by V1. है ना बेटा? So you are going to have this. Now this V1, V2 will go up and you will have 2V1 into V2 upon V1 plus V2. Now we know the value of average speed. When he was going to school, the average speed was 20. So V1 is 20 and V2 is 40. Substitute these values over here and finally children, we will get the answer as 80 by 3, that is 26.67 kilometers per hour. I hope the numericals for average speed and average velocity are clear to you. When we calculate average speed, it is total distance by total time. And when we calculate average velocity, is total displacement by total time. Okay, beta? Thank you.